Continuation with page number 7. The element of volume d cube r d cube v may become distorted in shape as a result of particle motion. The relation between the new element of volume and initial one is given by this expression, that is d cube r dash d cube v dash equal to absolute value of j d cube r d cube v. This is equation number 5, where j stands for the Jacobian of the transformation from the initial coordinate rv to the final ones, that is r dash v dash. The Jacobian j dash, absolute value of j dash is 1 here, is taken as 1 here. So we have equation number 5 can be reduced in this form, that is d cube r dash d cube v dash equal to d cube r multiplied by d cube v. This is equation number 6. Now equation 4 becomes f alpha function of r dash v dash and t plus dt dash minus f alpha function of r v t multiplied by bracket closed multiplied by d cube r d cube v equal to 0. Now this is equation number 7. Now the first term of the left hand side of equation 7 can be expanded by in a Taylor series about f alpha function of r, v and t as follows. Now we can expand it like this: f alpha function of r plus vt, comma, function of v plus a into dt and function of t plus dt, bracket close. This is equal to f alpha function of rvt plus within bracket delta f alpha upon delta t plus vx del fx upon del x plus vy del f alpha upon dy plus vz del alpha upon del z plus ax del alpha del f alpha upon del vx plus ay del f alpha upon del vy plus az del f alpha upon del vz multiplied by dt. Now neglecting the terms of the order of dt whole square and higher using the del operator relation, that is del equal to cap x, that is unit value of x multiplied by delta x plus cap y delta by delta y plus cap z delta by delta z. This is equation number 9. Now we obtain from equation 8 f alpha, we obtain from equation 8 f alpha function of r plus vt, comma, v plus a dt and function of t plus dt, bracket close. This is equal to f alpha function of r, v and t plus within bracket delta f alpha upon delta t function of r, v and t plus v dot del f alpha function of r v t plus A del V F alpha function of R, V and T. This is equal to 0. Now this is equation number 10. Now we will also use del V. Here we have also used del V equal to cap X delta by delta Vx, cap Y delta by delta Vy plus cap, it will be cap Z delta by delta Z. It will be cap Z. It will be cap Z and delta by delta Z. It will be not 1 by Z, but it is cap Z, delta by delta Z. Now, distributing the result of equation 10. Equation 10, just go through the equation 10 in substituting the result of equation 10 in equation 7. We have delta F alpha upon delta T function of R, V and T plus V del F alpha function of R, V, T plus A dot del with subscript F alpha subscript V del V multiplied by F alpha function of R, T and V. This is equation number 12. Now, which is Boltzmann equation in the absence of collision? Now, this equation can be rewritten as, capital D F alpha function of R, V and T divided by dt, which is equal to 0. Now, this is equation number 13, where the operator capital D divided by dt equal to delta by delta T plus V dot del plus A dot del. This is equation number 14. Represents the total distribution function with respect to time in phase space. Now, equation 14 is a statement of conservation of density of representative points in phase space. So, Boltzmann equation, which is represented by equation number 13 is a statement of conservation of energy of representative points in phase space. So this is one very important equation, that is Boltzmann equation is very, very important equation, and in this case, in your course, the collisionless Boltzmann equation you have to derive. Now let us discuss the Liouville's theorem, which is in continuation with the Boltzmann equation. Now if we move along with a representative point, that is F alpha function of R, V and T in its neighborhood, we find that this density remains constant in time. This result is known as Liouville's theorem. Now note that these results apply only to the special case in which collision as well as radiation losses of production and loss of particle are very important.